Okay, looks like we are ready to get started. If anyone didn't see their screen advance to the next slide, please speak up now and we'll address it. Well, don't actually speak up, but use that little comment pane on the right side of your screen and we'll get back to you. Today's webinar on managing large CAD assemblies is made possible through sponsorship from Siemens PLM, so thank you to them for that. Today's topic is a response to the complexification of designs. That's not really a word, but you get what I mean. It's just that as designs become more complex, assemblies become larger, and your CAD model performance deteriorates, sometimes to the point where it's just not usable. So with us today to help designers understand what they can do to improve the performance of large CAD assemblies are Ken Versprille and Matt Lombard. Dr. Ken Versprille heads the Design, Creation, and Collaboration Research Council at SimData, and he's recognized for publishing the first description of NURBS, which have become an international standard in CAD and computer graphics. Matt Lombard is a mechanical engineer. Matt has over 20 years of experience working on a range of designs, from managing fixture design to complex plastic assemblies, but he's probably best known for his popular books about CAD, including the SolidWorks Bible. He is now the community manager of Siemens Solid Edge. Now, before we get started, please locate the message pane on the right side of your screen. That's where you can type in your questions, as there are a very, very large number of participants in today's webinar. I encourage you to type your questions in during the course of the presentations. We will save some time at the end of the presentations for our speakers to answer your questions. So as the slide says, I'm John Hayes. I'm your host for the webinar. To make this whole webinar interactive, we have a couple of polls interspersed throughout. So when those times come, we'll cue you and ask you to participate in the polls and share the results with you. So without further delay, I'd like to turn the presentation over to Ken Versprille. Ken.
Thank you, John, for that introduction. It's my pleasure to be here today talking with you about what's become a very important topic in CAD modeling, large assembly performance. John has already made mention of some of my background. My entire career has really been centered around CAD modeling, with experience in the design and implementation, core development of CAD capabilities, and then working closely with industrial companies to improve their use of CAD. I can remember way back before there was even such a thing as a CAD assembly. Currently, I'm executive consultant at SimData. SimData is a management, consulting, and research organization whose focus is exclusively in product lifecycle management. We do both industrial client and solution provider consulting with the ability to do deep technical dives. So let's talk about large assemblies and the performance issue. Activating an assembly and then working with it can be crushingly slow. Each year, product models grow in size, and working in an assembly environment gets slower. It's a hot topic amongst all CAD designers. You don't really have to work in CAD modeling field very long before it becomes apparent to you that almost every CAD solution provider, each time they announce a new version of their software, will lead in the PR with some aspect of how we have improved assembly performance. It makes for good marketing, because as we all know, poor assembly performance can be a major roadblock to getting product designs done on time, and the performance frustrates you, the designer. With each new software release, users continue to call for better and better assembly performance. And every solution provider knows that in order to remain competitive, they need to have a laser focus on constant improvement. So we can ask ourselves, why are product assemblies increasing in size across all industries? What trends are fueling assembly growth? Well, first, we need to look at the major trends affecting all of PLM, at which point three obviously jump out as major drivers. We all know them as the cloud and mobile technology, IoT, the Internet of Things, and additive manufacturing with 3D printing. You have to be asleep not to recognize how all three of these trends are affecting how we do product development and what is the content of the products we do develop. However, they can have a varying impact on the growth of large assemblies. Some will have a stronger effect than others. Consider IoT. More and more products will be web-enabled, forcing an increase in electrical design and its physical packaging within products, growing the size of those products' designs. Additive manufacturing methods, which often rely on faceted geometry, will increase the size of models within assemblies. There are other trends that influence CAD, including the market push for more and more product customization, and the interaction of the supply chain for both regional markets and individual requirements has felt its presence in design and design assembly size. Let's take a little closer look at these trends. One of the most obvious is that products are becoming more sophisticated with an increased number of capabilities. For example, what used to be a basic mechanical engine farm tractor now has evolved into an unmanned autonomous vehicle that can follow pre-mapped guidance routes, can do automatic obstacle detections, and offer real-time views through onboard cameras. And then there's one of my favorite products that I've shown before in different presentations, the Mega Swiss Army knife. It just screams complexity. Another trend is the increase in customization. Special product versions for different geographical areas or simple individual choices. And the customization can take all forms, from something simple as color to something more complex like added-on options. All that drives towards multiple product configurations that must be captured in digital form. A common approach to manage all this product flexibility is the definition of a modular product architecture, products that are created from common building blocks. Yet, that all adds yet more structure to part assemblies. Other aspects come into play as design methods grow in sophistication. One aspect we often see at SimData that actually provides us a sense of the maturity level of our industrial clients is the amount of use they get from CAD model templates that capture their company's intellectual property. These are predefined component models and subassemblies that are generated based on input parameters and the company's best practices. They are then inserted into the current product designs and contribute to the growth of the overall assembly structure. The more predefined component models, the bigger the assembly structure. Another sign of design sophistication is a growing reliance on the supply chain to deliver lower cost components or special expertise components. The same holds true for companies that keep a library of existing components and subassemblies that the reuse in their current design products. Again, their use adds to the current product assembly structure. And it's a sure bet that many of you are working on a current product design with the need to either reduce its cost or its weight. I couldn't count the number of times when I've asked a CAD designer what they are working on today, and they reply, cutting costs, and then roll their eyes. There are many ways to cut costs, from removing minor variations in the geometric shape and standardizing on common shapes. Buy versus build using the supply chain or standard parts. At the end of the day, however, many of these add to the size of the product assembly structure you have to deal with on a daily basis. Take a moment here and do our first polling question. you'll see on the screen what are the business drivers you experience that result in large product design assemblies. We would ask that you would check all that apply and hit submit. Make sure if you're looking at a small screen that you do scroll down to catch all the different options. Give you a minute here. Make your selections and submit. See if this works. Okay. Interesting. Added product functionality, customization, multiple product configurations, with some reuse leading the way. Yeah, as I would expect. Very, very telling. It gives you a sense of, you know what answers you supplied. You can compare yourself against a good subset of the industry participants who are listening in on the webinar as to what they're doing also. Okay. So what can you do? Well, can you want to wait for the next software release? No, that's not really going to help you today. You need to be proactive and find some immediate solutions that fit your designs and the design methods you use. Now that's critical. First, you really do need to analyze your models. Look for common aspects of what kind of models that you build and work with. No one solution is going to work for everyone and every product. There are 3 different actions that we often recommend at SimData that a designer take. First, simplify your models and subassemblies. Well, what does that mean? If you're adding fine detail to the geometric model shape, before you've even settled on some of the major aspects of the design, then you're carrying a lot of baggage around as you do those major aspects. There are 100 possible things you can consider in order to simplify. In just a few minutes, we'll hear from Matt Lombard on some of the ideas that he has garnered. He deals with CAD usage on a daily basis. Second, that CAD wonder function that 2D drawings automatically update when you change to the 3D model can actually be a double-edged sword. It takes time to do those updates. Depending on the settings you have for the interaction you have between your 3D models and your 2D drawings, you can actually be dragged down in performance as you do interaction with the 3D model. We suggest you review your design methodologies and how you deal with the interplay between 3D models and drawings. There, depending on the software you're using, can be many very different aspects and controls that are available to you. Finally, consider whether you are a product designer or a demo jock trying to sell the product. Do you really need to turn on all those heavy shading tools, shadows, and lighting? They don't come at a free cost. They are not compute free. Every year your product designs will grow. It's been a fact for the last decade and shows no sign of slowing. You need to have a continuous improvement plan on how you will deal with that fact. You can expect new trends to emerge yet that will add again more to the challenge. You need to understand their impact and devise design approaches that minimize their design performance impact. Well, I'd like to thank you for the time to be able to speak with you today. I'm going to turn it back to you, John, so we give Matt time to talk about some of the concrete steps designers can take along these lines.
Got it. Thanks, Ken. So thanks to all of you online who participated in the last poll question. And you might be curious about model complexity and the rest of the folks on the call. And so we've got a poll question for you that sort of simulates model complexity. And the question is, how large can your CAD assemblies get? So if you would please take a moment to answer by clicking one of the radio buttons and hitting submit. Now I recognize that part count is not a good measure of complexity, but it's a really simple measure to use that you can answer in a single click. So it's the one we're going to use for today. But if you could, please just take a moment, and then we'll see, and then we'll show you what the results are. All right, let's go ahead and take a look here. Oh, okay, well, it's pretty evenly split. I mean, some of you have more than 5,000 parts. In fact, it's a pretty even distribution. And that's not to suggest that an assembly with more than 5,000 parts is necessarily more complex than one with 1,000 to 5,000, but that's a lot of parts, a lot of sub-assemblies, I'm sure very complex models. So now we're going to turn to Matt Lombard to actually help us with some more concrete suggestions as to exactly techniques that you can use to manage those large CAD assemblies.
Thanks, John, and thanks to Ken also for that enlightening presentation. I want to continue on that theme of defining what we mean by large assembly, because everybody has a different idea of this, as you can see from the polls, because there are people here with what other people would consider small assemblies or relatively small assemblies that are interested in learning more about large assemblies. The obvious measure is the one we've used here, is just the number of parts. The cruise ship model shown in the image on the screen has over 2 million parts. Assemblies of this size are certainly manageable if you have the right tools and the right techniques. But there are other measures of large assemblies. They might be the number of in-context relations, for example. We all know how much that complicates your design. Injection mold designers might make assemblies with fewer than 100 parts, but these can still be very compute intensive because many of the parts have active relations between the parts in the assembly, and they have other things like assembly features and patterns of parts and some complex geometry. So if you have an assembly that you wish that you could work with more quickly and efficiently, you can benefit from some of these tips. And we'll just define a large assembly as any assembly that makes you wait for your computer hardware. My presentation is going to walk through a few of the high-level concepts that you're going to need to keep in mind to keep your assembly models in top shape as you work with them and they continue to grow. You might consider adding some of these suggestions to your CAD best practice documents if they aren't there already. I know a lot of you keep best practices in a list or in a formalized document that you give out to your employees. We're going to start with planning, of course, because if you start to use best practice after a problem assembly has already been created, well, you're going to have a bit of a mess to clean up. So it's best if you start working correctly right out of the gate. One of the things that Ken mentioned that I want to mention again is the use of templates to standardize company information. So you might have a lot of metadata that you want to see in various places associated with your parts. And the best way to do that is to have start templates that have that metadata already built in so that you don't have to count on users remembering to enter it every time. So it's best if you start working correctly right out of the gate. Using templates is a great way to do that. And as you might imagine, planning to work with a large data set involves more than just CAD. And we'll see what else we're talking about in this slide. You have to start preparing your work area. You have to think that far back. The first thing you need is a comfortable chair and desk. This seems obvious, but you got to pay attention to ergonomics, and your employees are going to be spending a lot of time in this one location. If you want them to spend time there, it needs to be as comfortable for them and work as well as you can make it work. You need to provide a large visualization area. This means high-quality, large-size monitors, multiple monitors, especially if your assemblies have a wide range of size parts, so that you can still see the small components while the large assembly is on the screen. You need to be able to see everything from bolts to bulkheads. You need great visualization tools. And this is not really just for the CAD operator, but also for that constant stream of people who come to look over his shoulder to see what's going on. Come on, own up to it. You know you do it. Everybody does that. And you go into the CAD room to see how far the CAD guy has got through the design. A good computer will balance the processor, the RAM, and the video card. And as these components in the marketplace change frequently, you may need to consult with an expert to keep up with the latest technology to make sure everything in your system is balanced. Of course, you also need to be efficient with your money, so buying the extreme top-of-the-line equipment usually comes at a premium. So you may choose to back off buying the absolute latest cutting-edge processors to save a significant chunk of change. High-end computers should be replaced every 2 to 3 years, keeping an eye on how your people work. If they're spending a lot of time waiting for the screen to refresh or for parts to rebuild, you may need to update some equipment. Also, don't forget peripherals can add a lot to productivity. A good mouse, I use the Logitech M705. It makes a big difference. It feels good in the hand. It gives you the buttons that you need. It gives you some customization. Also, a 3D mouse or Spaceball from 3D Connection can be fast with view manipulation in the palm of your hand. Some people make peace with these things quicker than others, so it may not be for everybody. But for those who enjoy them, it's really a time saver. Literally able to go at the design with both hands. And then, of course, we have the IT-related components of a good workstation, such as a fast, modern network to handle all of the large data sets that are going to be going back and forth. And also a data management system to help multiple people work on models at the same time and keep all of the revisions straight. We'll return to the topic of the advantages of data management in a later webcast, but you can't really be overstated how important that is. Within your organization, your CAD data performs many functions. You might perform a motion analysis to find the center of mass, use it to design shipping containers or crating, motion studies, renderings, bill of materials, assembly instructions, service instructions, and who knows what else. It may not make sense to use the same assembly file for rendering as you use for motion studies because of the extra props or the special positions that you put your assembly in. Don't be afraid to make a separate assembly file for separate purposes. If you use the same assembly for everything, you may have to destroy one type of information to create another. And just make a copy of the assembly and the related sub-assemblies and use the same parts and go on with your work. You also need to understand the cost. This is something that Ken mentioned earlier, the cost of each aspect of the assembly and of your work with the assembly. Features like assembly features or in-context relations between parts can be very costly from the performance point of view. Fancy display settings like reflections, shadows, textures can also add to display calculation time, and we'll talk a little more about this later. Large patterns, parts with complex faces, such as screws with helical threads, knurled surfaces. I know as a CAD user myself, it's very gratifying sometimes to make an incredibly detailed model that's got just every little fillet is perfect, and it's got extruded text and all of this on it. That can all be great and very gratifying to see, but does it really add any value to the end product that you're trying to create? If you have a highly detailed model of something, make sure that you also have a simplified version of that model as well that has the pertinent, it still has the pertinent information, but it's not going to bog down the system with unnecessary edge displays or unnecessary complex faces. Maybe the simplified version is just a head showing the drive type and size of a particular bolt. Or if you purchase a driver cabin for a piece of construction equipment that you design, the detailed version of the cabin with all of the controls is nice for the rendering, but it may be completely overkill for the system assembly drawing. So moving along here, as we started to mention previously, simplification is one of your most effective tools in the battle to keep assemblies working their best. This goes for parts and for subassembly components. Simplification is something you should practice as you build up the components that make up the large assembly. If you wait until the end of the design, it's going to be too late. If you have simplified versions available when you need them, just makes it that much easier. Simplification does several things. First, for the computer, it makes the geometry easier to compute and to display. Also, for the human, it makes things easier to understand visually if you don't have a lot of unnecessary visual detail and clutter that's on the screen that you have to sort through. Remember also that not all the people that look at your models, renderings, or drawings are going to be highly skilled visual or technical people. Some may be from sales or purchasing or shipping or anywhere else in the company, including management. So if the detail is not necessary to communicate what you need to communicate, then remove it. Okay, we'll talk a little more about simplification. Simplify complex shapes into simpler, primitive shapes. You cannot see most of the detail of individual parts at the zoom level required to see the entire assembly. So as I mentioned before, remove the threads from the bolt. You really don't need that. Volumes, in fact, CAD Bibles have been written about the best practice for modeling parts, especially in history-based CAD, where your entire experience with performance is based on following best practice tightly. I won't rehash this here today for parts other than to single out complex shapes and large patterns or features. You can simplify subassembly components into single parts. You can see in the picture behind the slide here, we've got a piece of equipment that was simplified as a block. That's really all the information that you need at a certain level in the drawing. Obviously, if you're down in the subassembly level, you need to see how that piece of equipment works and how it connects to other things. But really, all the information you need to know is where it goes and how much room it takes up. Does all of this sound like a lot of discipline to follow? Well, yes, it is. But you have a large assembly to manage, and the larger the assembly gets, the more work it takes to manage it. And if you have all of this in mind when you start, and you have planned out your course of action throughout the design process, it'll get easier for you every time you do it. And you will start to add your own ideas based on the unique design requirements that your company has. One thing I'd be remiss if I didn't mention is synchronous technology. In context relations in traditional history-based design methods are a huge thorn in the side of CAD operators trying to make very large associative models. And if this were a presentation with a little live audience at this point, I'd ask everybody who's banged their head on the table before because of in-context relations in your assemblies to raise their hand. And I expect at least half of the group to do that. The most effective way to deal with in-context relations is simply to stop using them. And I know that's easy to say from where I am here, but synchronous technology gives us the ability to do that. It's an alternative to history-based methods that enables you to edit 3D parts much in the same way that you traditionally edit 2D entities on drawings. It works without adding time-based relations that must rebuild to keep your parts up to date. Synchronous technology, you determine your design intent when you need it, rather than needing to establish it at the beginning of the design process when you don't know how you're going to use it later on. And at this point, I think John's going to take over for a CAD usage poll.
Yeah, since, Matt, we don't have the opportunity to ask people to raise their hands if they've had to bang their head on the table over in-context edits. So this question is around what CAD system do you use most at your company? And since you can only pick one, just pick whichever one you use most. You may have to scroll down to see them all because they're alphabetic. And we'll give you just a moment to answer those questions. And yeah, one of the other things, just for a point of clarification, when Matt talks about synchronous technology, that is also somewhat analogous to direct modeling solutions. So some of those comments that Matt makes with respect to synchronous technology, I think in some contexts you can also substitute direct modeling solutions as well. So yeah, if you could just take a moment, click the radio button beside whichever CAD system you use the most. I think we'll give you another couple of seconds to do that. And go ahead and click submit, and let's have a look at the CAD systems people are using. So there are lots of SolidWorks users as usual, Solid Edge and NX, Inventor, and other solutions as well. So thank you for that. And Matt, perhaps you could share a few more tips on managing large assembly models, if you would.
Sure. So as you can see, looking at this data, we're using a range of CAD systems. And if you count up all the time that you spend waiting on your computer to regenerate all the drawing views on a sheet, as well as the models behind the views, even if you can only save yourself a few seconds for each redraw, and this is regardless of what CAD system you're using, you could reclaim enough time to add another coffee break to your day, or maybe get a couple extra edits done before the manager comes back around. So there's a lot of advantages that we can have here. Let's continue talking a little bit about drawing. Drawings have a big job when it comes to large assemblies. Multiple views of each assembly, including multiple parts, potentially cutaway and detailed or exploded views, mean that your CAD tool has to manage the display of a lot of different states of the model. From a performance point of view, it might make more sense to make multiple drawings rather than make a single drawing with multiple sheets. This can put a large memory load on your computer and may slow you down significantly. This, of course, depends on your particular models and the density of your drawing views on the sheet. You can avoid interferences. This is one that a lot of people don't understand. If you have bolts that always interfere with the pieces they go into, there are some display algorithms that have a difficulty dealing with interferences and which part do they display when parts interfere. If you could avoid those interferences, that would save the CAD program a lot of extra compute time in some cases, especially for display. it means that your system is spending more time calculating that bad display than it should. The problem with detail is that it is costly in several ways. First, detail takes a long time to create. It's very gratifying to create a lot of detail, but it takes a long time to do it. Second, it takes a long time to display it every time you need to do so, so your computer has got to work that much extra. Too much detail can have a critical impact when it comes to drawing performance. Drawings must calculate every edge and then decide if they're hidden, shown, grayed, dashed, in this font, that font, some color, for every part, every time it's shown. Excessive detail can make your model look more realistic, but it causes performance losses as a result. And you can translate that pretty easily into missed deadlines. If you just need to determine ahead of time what kinds of things add value to your process, you can make that decision if this is the kind of detail that you need to put on your drawing or not. And part of talking about drawings is talking about the display, and Ken had alluded to this earlier as well. Special display elements can also be costly in your CAD models. Your computer hardware needs to be set up to handle these elements as efficiently as possible, but fancy display of your CAD data is not always the most effective use of your time. Sometimes you got to do it, but it's not always the best thing. So visual effects are fun. In my CAD career, I've had a lot of fun with the visual effects and making cool images and renderings, or even trying to make just the CAD model look as much like a rendering as possible. It's a lot of fun, but it's, when you're trying to get a drawing out the door, a set of drawings out the door, it's kind of a waste of time. When you have to communicate your design with non-technical people, or you have to create images simply for their visual appeal, the flashy image goes a long way. But maybe you have to create marketing materials before you have an actual product to photograph. And God forbid, I'm sure no one here would do that. I know I've never done that. I've got my fingers crossed. But working with visual effects on a day-to-day basis within your CAD model is very costly. And if you're working with large data sets that we're considering today, it's extra costly. So it's fine to use the flashy settings when you're working on individual parts or simple subassembly components, because the way your computer's set up, it'll handle that in small doses very adeptly. But when the going gets tough, you've got to leave these settings behind. Some of these are more costly than others, but there's a few types of items that you may want to turn off when you're working on an assembly that taxes your computer. And Ken mentioned some of these earlier: reflections, drop shadows, self shadows or cast shadows, silhouette edges. It's a good idea to use shaded mode rather than just the edge display. That's because of the video card hardware taking over some of that functionality. And if you have the option to use a single color for edges rather than multiple colors, that's also better. Use small edge culling so that the display isn't trying to work out very, very small edges that are only going to take a pixel or two. It'll drop those out. You work with the sharpness or the accuracy set as low as you can stand it. Some people don't like to see the circles turned into octagons, but if you can work with that, that will help the display and speed up the performance. There are several other things like this that when used together will greatly affect the performance of your computer when used with large assemblies. And that's the end of my presentation. We've got a little to say on Solid Edge in general. Siemens Solid Edge It's not just a single product, but an entire portfolio of affordable, easy-to-use software tools that address all aspects of the development process, from design to simulation to manufacturing, data management. Again, we're going to talk about that later, and then smaller apps that will help you with various aspects of your design. So design, industry-leading 3D design software combines the speed of direct modeling with the flexibility of parametric design, and this is what we were talking about earlier with Synchronous Technology. Simulation, the integrated simulation tools to digitally validate parts and assembly designs. It's for stress analysis, motion analysis, flow, thermal, you name it. Manufacturing solutions to accurately and efficiently manufacture parts, whether additive or subtractive. Data management that meets the needs of your growing business, and we have various solutions here from the very small to the very large. And powerful specialized applications that extend your capability. The ideal platform for you to start your digitalization journey is powerful, affordable, and easy to use. And with that, I turn it back over to John.
Hey, thanks, Matt. That was a really interesting set of insights regarding how to manage large assemblies. One last poll question before we get to the questions. So if the folks on the call could please indicate whether they're currently looking to make a CAD change. I think that really means they're looking to make an investment in new CAD software, and that's a yes, maybe, or no. That's a pretty simple question. And then we will get on to the Q&A session. We are right on schedule for that, so we will have quite a bit of time to direct questions to both Matt and Ken. So if you go ahead and hit submit there, and we will move along. There are just a couple other things I'd like to remind you about. There is a part 2 to how to get better performance when designing large assemblies that's coming up in a month from today exactly. So another live webinar featuring Ken again and Matt. So something that we can look forward to because we only could get through so much of the content in just one webinar. This is the URL if you want to sign up for that webinar right now. We will also email that to you tomorrow. And Siemens and their Solid Edge team has put together a whole series of webinars, and they are not all posted at engineering.com. You can access a number of those then from the Siemens website directly. Here's the URL for that. And again, we will send that to you in an email tomorrow, along with a link to the recorded webinar. People always ask us if there will be a recording of the webinar, and the answer is always yes. So look for an email from us on that tomorrow. So let's get on to the questions. Oh, and if you want to learn more directly about Siemens Solid Edge, these are some people that you can contact. So let's get on to some questions. A number of you have submitted questions during the course of the webinar, so thank you for that. If you have a question and you haven't submitted yet, please ask the question on the right side pane on your browser. So the first question comes from Dimitrios, and his question is, Synchronous Technology is a Siemens PLM technology. What is the equivalent for other platforms? I'm going to just mention, I know the other guys don't like to mention brand names a whole lot, so I'll just tell you that there are other direct modeling tools like Creo Elements Direct and from PTC, and ANSYS bought SpaceClaim, but they're not the same as Synchronous. And Matt, would you mind answering that question, please?
Yeah, sure. I recently wrote an entire book just to answer this question: what is synchronous, and how is it different from your usual history-based programs? And if you do a search for that, I think you might be able to find some downloads for that, for the 150-page PDF that has some videos and solid edge sample parts, and then you can get a solid edge download on top of that. But synchronous is not just direct edit. There's a lot of, synchronous is one component of, or direct edit is one component of synchronous. There's also a lot of tools in there that make it a completely parametric system, and there's even some associativity built in there. But associativity is one of the things that synchronous was actually trying to work around, because the associativity is what brings in a lot of the frustration with things like in-context design. In-context design is when you make relations between parts in the context of the assembly, and these are relationships that have to be rebuilt during the course of the assembly. And so when you make a change in the assembly, it takes a long time to update the individual parts and then update the assembly. And then if you make a change to an individual part without having the assembly open, then the associated part doesn't change, and you've got all these file management concerns that go along with it. And it's really at the end of the day, most CAD system users, when they create in-context relations of one type or another, wind up just simply breaking them at the end. So they've completely destroyed all of the design intent that they've been building in. Whereas synchronous technology just goes right around that, and you create the design intent as you need it. So obviously, if I wrote a 150-page book just on this topic, it's going to be difficult to answer in 30 seconds. But that's kind of a long-winded answer for that.
Well, thanks, Matt, because you also answered a question from Brian about explaining in-context relationships during the course of your response as well. So thanks for that. Another question, Ken, I'm thinking you might be the right guy to answer this one. It's a simple question, but possible to answer. Martin asks, what is more important, hardware or simplification in this context?
Well, I would say probably you've got to meet a certain threshold in hardware. I know, for example, I tell a story for where I was working with one of the very large automotive manufacturers in the U.S., and I was challenging them to do much better in collaboration software. They actually use the tools that they had available to them to collaborate with their supply chain. When the gentleman I was speaking with at the company said, Ken, you really don't understand. We're still on Windows 95, and we can't get off of it right now. And it became very clear to me, okay, their IT department was sort of buried way back in ancient times and did not have the money to really upgrade the underpinning of what the new tools expect to have underneath them. So I would say hardware is your first choice. Look for a certain minimum. I think Matt said it right. You don't want or need the top of the line. Maybe the second or third down is good enough. Always a lot of memory helps. Then I would look to simplification. If you find, like I said in my presentation, you really need to analyze the kind of assemblies you're working with. If your assemblies have a lot of detail, such as thousands of bolts, and you do have the threads on them, well, there's an obvious screaming area that you can take a look at.
Okay, thanks, Ken. So here's a question. I think, Matt, this might be directed more to you. What is more efficient in terms of computing resources? Is that mirroring a component into the assembly or placing a second one into the same assembly? That came from Misko.
I would, personally, I would reuse data as much as possible. So if you've got one file, you'd you'd be better off placing multiple instances of a single file rather than even making a copy of that same file and then needing to reload that file into memory. So now you've got two identical files loaded in memory rather than having a single file loaded in memory but displayed in multiple locations. There's a lot of ways to skin that cat, but yeah, I think reuse of data is a really good thing.
Well, here's sort of another question along that same line. What about what radiuses require less computation? Ones that are made with ordered technology or with synchronous technology?
Say that again?
Yeah, so he's asking what radiuses require less computation, and maybe I suppose apply to other features as well. Ones made with ordered technology or with synchronous?
Well, you use the word radius. What radius is?
Well, that's what the question said. I mean, he may be able to apply that to other features or geometry.
Well, in general, the synchronous technology is going to require less resources in general, because it doesn't require the rebuild of individual components, and so it would be like in a history-based system, it would be like having a bunch of imported parts, where you've got the geometry on the screen and that's it. Synchronous technology gives you a way of working with what other systems call dumb geometry, but in synchronous it's not dumb at all. It's completely editable, and the software even recognizes things like patterns and different types of features. So yeah, I would say that synchronous is going to have just an inherent advantage because it doesn't require the rebuild of a history-based feature tree.
Okay, thanks for that. I think that answers the question, but if we get a follow-on question, we'll know. So another question, I think this might be best directed to Ken. John is asking, in terms of managing large assemblies, what about design automation tools like Autodesk's iLogic? Is there a role for those sorts of tools in managing large assemblies?
Oh, I think definitely yes. One of the things I look for when we first go into a new industrial client is we try to get a sense of what I call their level of CAD maturity. And we have a matrix that we look at, and for certain key pointer issues, we have 5 levels of maturity within that axis that we sort of look for. We interview the designers and the managers and try to understand whether they're actually doing some of this. It can range from, for example, one of the axes might be on form features. Do they use form features at all at a very low? If they say no, then they're at a very low maturity level. Working all the way up to not only do they do form features that the solution provides, but they have their own library of custom form features. That moves them up higher into the level of maturity. Anything with logic that can be put into a template that can be run, and the logic really is assessing based on the parameters being fed in and best practices that are built into the construction of the component models that these library parts are creating is going to be a help. If nothing else, it gives the management a understanding of they're comfortable that certain standard procedures are being followed. Otherwise, it's a free-for-all. each designer can do, especially in a large company, if they could do whatever they wanted to do, there's no consistency at all. There's no guarantee best practices have been used. And one of the things, for example, we look for is, I'll ask them, if you do have these templates, do you have a checker tool that can scan through a part design and determine how many of them were used? And that gives the management a good signal as to are they taking advantage of the captured knowledge of the company.
Okay, well, thank you, Ken. I just wanted to also thank everyone who's asking so many questions. I have to apologize to you in advance that we do not have time to answer all of the questions. So if you don't hear yours come up, our apologies. There may be a way if you have a specific, I'm going to avoid the more specific solid edge sorts of questions, and maybe you can reach out to the people on the screen for those sorts of specific ones. But Georgios has asked one that's really quite a broad question, and Ken, I think it's really up your alley. He asks, how can we convince our employer to change from a CAD software to another when our current CAD software is no longer covering the needs of our projects?
Well, I think you've got to be able to justify that statement and prove it. And it's got to be a concrete proof. It just can't be opinions. You've got to have some metrics that are very concrete metrics that prove the point. Can you
provide some examples?
Well, how many ECOs typically will happen on a new design? Where in the design process do you have schedule delays? Does it happen when you're doing the details of the design? Does it happen when you're doing drawings? Does it happen when you're doing assembly instructions? Where along the lines is the roadblocks? And then zeroing in and understanding what is there or not there as a tool to support better performance. And like I said, you've got to really bring it down to concrete facts as best as you can.
Okay, thank you. I'm going to say we have time for one more question only, and apologies to the rest of the folks, but I'm going to go with Peter's question here. He said, recently there's a lot going on in the product and manufacturing information contained in there's a lot of information embedded in a model, like GD&T, specs, processes, and so on. And is there an easy way to carry over that information into an assembly model? I'm trying to think about who might be best to answer that one. Matt, do you have a suggestion there?
Well, the metadata is there's a lot of ways to include that. Sometimes it's appropriate to put it at the part level, and if you've got the right the right part templates set up, you'll have information that goes into these parts, like you can have your supplier, the material, the process, you can get down to the individual part cost. You can put a lot of different types of information. Some types of information are better just put in the assembly as metadata that can be accessed through the PDM product that you're using. There are other types of information where you've got more of a narrative or something that many CAD systems allow you to put like a text file or a Word document actually inside the CAD file. Short of that, you might, in your PDM system, you can associate different types of information like an Excel spreadsheet of test data or something like that. You can associate that information with the assembly or with a particular part within the PDM system. And that's often an effective way. There are a lot of different types of information that can be associated with your with your CAD data. And I think if it's not just simple metadata, then the best way is probably to link it as a document within whatever PDM system you're using.
You know, let me jump in here also. One of the things we talk about when we meet with our industrial clients is the need for them to have a data model. And when we say data model, we mean a blueprint for what data is that they're going to store, author and store, and where it is. Is it in a data management system? Is it at the assembly level? Is it at the component level? As Matt said. They really need to come up with a very conscious drawing of that blueprint and then adhere to it for all the models and all the designs that they do. Then everybody in the organization knows where to look for a particular type of piece of information because there's consistency to it. And second of all, they can actually automate some of that stuff because now they could program custom little apps to do certain things knowing exactly where the data is.
Got it. Thank you, Ken, and thank you, Matt. And I appreciate to both of you that we've run a little bit over time, and I appreciate your flexibility to answer that one last question. To everyone on the call today and on the webinar, thanks for joining us on this webinar on managing large CAD assemblies. We do have that other webinar coming up on this topic next month, so I encourage you to sign up for that. We will send you a follow-up email tomorrow with a link to this recorded webinar, links to where you can get more information, and also a link to where you can sign up for the webinar next month. Special thanks to Ken and Matt for doing a wonderful job today, gentlemen. Very much appreciated. And to our sponsors at Siemens PLM. That's it for the webinar. And so on behalf of engineering.com, I'm John Hayes saying thanks very much, and I look forward to seeing you on March 23rd.